Very good evening, guys. Can you guys hear me? Can see me? Let me know in the chat. Very good evening, Nilanjan. How you guys are doing? Have you guys practiced whatever we have learned in our previous class? Very good evening, Ankit. Very good evening, Ashwin. I'm doing good. Ankit, what about you guys? So yeah, Dasahara is coming. So are you guys excited for that? Because in my nearest place we have, I think, big fair, Mela type. So definitely I'm going on Wednesday. What about you guys? Yeah. I'm saying it's coming in, I think, Wednesday. Oh yeah. Nishant is excited more for Diwali. Very nice. Yeah, I think October is full of festivals. So yeah, definitely. So yeah, you guys tell me, have you guys practiced whatever we have learned in our last class about the linked list? So when we ended our class, I was getting the feedback that you guys was very excited to practice it, and you guys has also enjoyed the session. So have you guys after that practiced any of the operations in the dry run? Because I told you the linked list is more on the visualization part. So how much, like, how much you can visualize the things or operations in the linked list, you guys would be very happy to write the code about it also. Sure, Nishant. We will. So before talking about again linked list, who has solved the problem which I have told you to solve at the end of our previous class? I told you to find it out or insert any element at the specific index. Anyone has practiced that one? Nobody has practiced? Okay, so it has practiced. Can you share your code? So is it uh, like you have solved it or still you are working on it? Ekta. Ah, great. Congratulations. Very good evening, Hariharan. I had fast for whole day today. So in meanwhile, my voice could be like ups and down. So let me know when you guys feel little bit low energy today because I was just having a fast. So I think yeah. So let's see. So let's start recapping. So Ekta, I would request you to add your code in the doubt section so I can see your answer or what approach you have followed. Okay. I'm doing good, Hariharan. I'm expecting the same for you also. So we'll wait for 1 more minute and let's see if Ekta is adding the screenshot so we can look into that one and then we can jump into our first we will recap whatever we have completed and then we will continue from there. So in meanwhile, I have shared one screenshot where we will comparing about array and linked list. I hope you guys have seen that screenshot, and it might be clear some of the doubt of yours, when to choose array, when to choose linked list. I hope that screenshot has answered that particular question. So I have shared it on that group. So we'll share it. You can just go through and check again. Hariharan. And so let's see. So we have started with, in our last class, we have started with understanding that the information is all around us. Hariharan, I will give you the name of the group, and then you can connect there. It is LinkedIn group. So I will just share the name with you, or somebody can share it from here, or invite you if you have already connected there. So you can join that one, and then you can see there that is screenshot. Okay. Okay. So let's recap whatever we have completed in our last class. Okay. So I remember we have started with understanding how the information is all around us, right? And we have talked about like how much importance that informations play, because if you talk about any of right now, then like people has started saying like that data is a new currency. People are working on AI, MLs, blockchain, everywhere they are working on data only, right? So once we see the importance of data, now everyone wants to capture them, right? Everyone wants to store them. So for storing this data, we have a lot of tools available for us, right? A lot of tools are available to us. But the real problem is that how to store these type of data? What is the right tool to store this type of data, which is like available in everywhere, or trillions of data is available. But what is the best tools to choose to store these type of data? Right, there are a lot of like, if you talk about data structures, so a lot of data structures are available for us. Arrays are there, linked lists are there, stack, queues, trees, b trees, hash map. A lot of data structures are there. Some of the data structures are extended version of some of the existing data structures like b plus tree, graphs, right? So these are the ways to store these data or organize this data, so we can easily interact with this data. Because once you store the data, what do you want to do next? You want to interact with this data. You want to find some patterns, correct? Sure, I will see your this one after recapping. Okay. So that's why the need of data structures comes into the picture. Once we understood this thing, after understanding the need of data structures, I told you that linked list is also one of the data structure or tool to store data, right? After understanding this thing, we have jumped onto the topic of linear data structure and non-linear data structure. I showed you one example of one game also, where we have seen the data was assigned in the sequential manner, right? And in non-linear, that data was not organized in a sequential manner. And then we talked about in the linear data structure. Yes, Joseph, that's right. So in the linear data structure, we have talked about that arrays and linked list comes into the linear data structure. Correct? We store data in a sequential way. We can traverse the linked list in a sequential way. Like one, we will start from the zeroth index, like how we traverse in the array. We start from the zeroth index, then we move one more index, like one index to the whatever index we want to go, or till the end of the arrays. That's how we traverse in the array. In the similar way, we traverse in the linked list also. We start from the start node, and then till we found the last node, where the in the last node, because every node has two parts, then we discuss about the linked list specifically, right? And then in linked list, I told you that there are like three things which are very important. One is node, which is very important part of any linked list, right? They modify the linked list also based on these nodes only, correct? So in the nodes, every node has two properties. If you talk about single linked list, then every node has two properties in single linked list. One property is value, where we will keep the data which we want to store, and then there is one more property that node will has, and that property is next, the address of next node, because we want to combine data, right? Like if in the array, if you talk about array, so in array if we have 6 elements, so those are all combined, we can easily traverse them. In similar way, with the linked list also we want the same feature. So that's why in each node we have the next property also. The name of property is next. We can say anything, but with our examples I'm taking it as a next. It is just simply telling us what is the next element, what is the next element from the current element, right? If I am standing in the current node, if I want to go to the next node, how can I go it? So with the next property, that tells us. Okay, that was the one thing about the linked list, single linked list. And that's two more things I told you about to understanding where to start and where to end in linked list. Because if we have one linked list, so we should know from which place or from which node we should start, and at which node we should end. So how we achieve this thing? So there are multiple ways to achieve this thing. For start, we always go with the we always for starting node, whenever we create a linked list, by default we take some pointers. Those pointers are start or tails. In some scenarios we do not take the tails pointer, because what tails provide us the end of linked list. So we can find out end of linked list in two ways. One is, if any of nodes next property is null, it means that node is end node. It means that node is end node in linked list. So that's why, or we can have one pointer. So whenever we are inserting any elements in the linked list, we can easily move our tail pointers to these elements. So we can track the end of linked list in two ways: with the tail node, with the tail pointer, or with the node also. So whenever the node is ending with the whenever nodes next property is having the value of null, that's also the part of end, right? Let me show you also very quickly what I'm trying to say here. You guys are able to see my screen? Let me come back to chat. Yes, thank you. So what I was trying to say here, guys, so linked list has single, if we talk about single linked list, so it has first node. I told you each node has two properties. One property is value, and another property is next. In value, we keep the data like 1, 2, 3, 4, whatever we want to store that data. And in the next property, we keep the next node address or position. Next node address / position. Correct? That's what we have in the each node in the linked list. Then I told you about the start and end. Means where linked list is starting. Linked list is starting. Where linked list is ending. Correct? Then I told you for starting, we have one pointer that's called start pointer. So every linked list has a start pointer. Correct? And for ending, there are two ways. For ending, there are two ways. One is through tail. We can have one more pointer, which we say at tail pointer. We can have one more pointer, and we can say that it has a tail pointer. So whenever we are inserting any element, we'll see that if we are inserting this element as the end, so we will simply move our tail pointer to the new element. Correct. With that, we can easily track our last element. Otherwise, the best way, which most of the time people follow, what they say that if node key next property, node has two properties, right? Val and next. If node's next property is equal to null, so this node is also the end node. This node is going to be ending node. Correct? Correct, guys? So that's what will tell us that where our linked list is ending. So these three things are very important. Other than that, we are good. Other than that, now questions will come, like a lot of questions will be there in the linked list. But the basic things are these three things you should know. And after that, whatever we need to do, it's just all the logical things, like how to move to next node, right? How how to delete any node, how to insert any new nodes. These are some of the operations and logical wise things. But these three things are very basic. Okay. And now, if we talk about this was single linked list, right? If we talk about double linked list, everything is same. Start will be there, end will be there. Everything is same in the double linked list. Just difference in the node. Now, in the double linked list, guys, node will have three properties. Well, same data, it will keep the data, right? Like 1, 2, 3, 4. And next, it will also have next. Same like single linked list. It will tell the next node address slash position. Next node address slash position. And this will have one more property, guys, which would be previous, where we will get to know about previous node address slash position. Previous node address slash position. अब देखो लिंक लिस्ट हाउ दिखती कैसी है, how that does it look like, what is happening this. Okay, I'm not able to go to the further, not sure why. So let's open a new page. I was just expecting if I can go up. Okay, it's not happening. So let's open a new page. So say okay, it was new page. Very weird. These things are looks like written on my screen. See, I cannot go. If I'm going to the next page, these things are coming there. Very weird. Let's see, delete them. It looks like my computer is not working fine. Let's try it again. So see, guys, how the linked list look like if you want to simply visualize it in a how would we are storing in the computer. So it looks like this. If we talk about the double linked list, it will look like this. This is our node, right? What is happening? This is our node. This is our node 2. Okay, something is happening, not good. Okay, let's try it again. Let me close it, guys. Might be possible because of that is happening. Let me open it again. Okay. Okay, so whatever we have drawn, it has gone. But let's see, this time it is breaking. No. So see, guys, how they look like if we want to visualize it. So this is first node, we can say. I'm drawing right now double linked list. So it will have three things, right? One is 4. This is the data val property. This will have the next address. So I'm just keeping at n. This will have the previous address. So see, there will be multiple nodes, right? This is second node. This is node 1. This is node 2. Node 2 will also have some data. It will have the previous address, which would be pointing out to this. This will be next address if there is any element. If there is no element, it will keep null. So that's how these linked list looks like. Okay. So, and yeah, there is one more, right? There is one more. That was circular linked list. Apart from like after double linked list, there is circular linked list also. So what happened in circular linked list, guys? Last node, rather than pointing to null, it points to previous node or the head node. Like if we talk about single linked list, let's, because with double linked list it just becomes a little bit complicated. So let's take single linked list. So in single linked list, 1 minute. Yeah, in single linked list, guys, we have 4 and we have next, which will be pointing out to next node, right? And here it would be our head, correct? And there now you see this is our next node, which is pointing out to next node. So if I say in the same example, let's take one more node, right? That will give us more better view. So now this is pointing out to this node, correct, guys? Now, in the single linked list, what will happen? We will keep here null because this is our last element, right? We'll keep it null. But in the circular linked list, we do not put null here. We just simply point it out to first element. Point it out to first element. So we can say this is our tail. Tail is pointing out to head. So that's mean there is no null at the end. If we want to stop the loop or stop the traversing, we just need to look for the tail address. If the tail address matches with head, so we will stop it. If tail address, you can see tail address, if matches with head, so we can stop it there. So that's how, guys, whatever problem you guys are doing, whatever operations you are going to do, you have to first do like this. In the drawing you have to do the operation first, then you have to do in the coding. Understood, guys? Everyone has recapped now, and I think after that we have started our insertion operation. So quickly let's see the Shweta's yeah, it's Shweta's doubt. Sorry, so not Shweta, sorry, Ekta. It's Ekta's doubt, and then we will, because I told you in the last class to solve last problem where we have to find, where we have to insert any element at the given index position. So Ekta has solved it. So let's see our approach, and then we will start. We will start this. We will continuing our lecture. So she has provided the URL. I'm not able to copy it, by the way. It's very weird. Okay, guys. Sorry, Ekta. Not able to copy it. So we'll see it later. Okay. See, I'm trying to copy it, but it's not happening. No problem. That's fine. I will try. We'll try. Okay. What is that? Ekta 30, right? Okay. 1 minute. Let me see it. No problem. Ekta 30, right? That was your repo. Yeah. What was the folder name? It's DSLGO.js, right? What was the folder name? DSLGO JavaScript. Oh, you see? Now I can copy it from here. Cool. When I chosen that question about doubt, I was not able to. So you guys are able to see my screen, right? Let me know in the chat. Yeah. So let's see our solution for this. So she has done the prepend, append, insert node position. Yeah. So that was the logic, right? We are looking for. So okay. So position less than 1. Less than 1. What about the zeroth index? That's not the that's not an invalid position. Ekta. Yeah. For the zero, it means somebody wants to prepend it. Understood, Ekta? If somebody wants to do okay, but that's not correct, right? Every time arrays or any of the linked lists which you have seen, we start from the zeroth index, right? So look for the zeroth, just modify your code for the zeroth index also. Zero would be your first index. Okay. But yeah, let's look further. I'm just not like ignoring all these things. I'm just coming at this part. So let count is equal to 1. Okay, so see again starting count is equal to 1. Okay. Temp is equal to this dot head. Okay. While count less than position minus 1. Okay. Hmm. So I think yeah, she is working on that one. She is like stopping it further position. So see, guys. So okay, let's see our question, guys. What was our question? Everyone, just look into my screen. I told you every time, whenever we are trying to solve any problems in linked list, we have to first draw some dummy linked list, and then try to insert there. Try to solve your problem there. After that, start reaching the code. So, क्योंकि देखो जब when we are solving that, when we are solving the problem in drawing, at that time automatically you will generate the code also. Okay. So let's jump into the, let's take some dummy example. Okay. So we can say this is our 4 element, which is pointing out to 5. This is our 6 element. Okay. And 6 is pointing out to null. When I'm saying pointing out, it means the for this node, the next property is equal to null. Okay. And our head or start at this place. Correct, guys? And now what we want to do, we want to insert a new element. And that element or that node is 7. Correct? And we want to insert it at this position. Correct? If you consider it as a 0, this as a 1, and this as a 2, so we can say we want to insert 7, insert 7 at second position. Correct? तभी तो जब हम 7 को when we will insert here, 7 will come at second position and 6 will come at the third position. So we want to insert the 7 at this position. Correct? अब देखो, if we brought this 7 at this place, so how will be connection will be? How connection should be there? Correct? So like all the nodes which are which we are pointing out from 5, they should be now pointing out from 7. Correct? All the nodes which are coming after 5, they should all come after 7, right? So what will happen? The new connection should be like this. First, it should go to it should go like this, and then from here it should go like this. Correct, guys? That's how you will insert 7 in middle of 5 and 6. Agree, guys? Right? Everyone agrees with that? Okay. And after that, this connection will break, right? And then this would be the permanent connection. For us, this would be the permanent connection. So see, what are the operations needed? So I told you 3 steps, right? First step was, while inserting any element, first step was create a node, which we already did. Create a node, which we already did. Second step was update the next property of this node. Update the next property. अब देखो, इसके next में क्या आना है? इसके next में ये link आना है. In the next part of this 7, this connection has to come. Correct? And how this connection will come? This connection is right now at this place. Correct? If I erase every this new connection and go to the original linked list, so you will see this connection of 6 right now at the fifth, this connection, all the connections of 6 will right now is at the fifth position, right? At of not position for this element. Right now, node 5 has all the connections to 6. So somehow, whatever is in the next of 5 has to copy it to 7. Correct? Whatever right now is available in the next of 5, the all thing has to copy to 7. Correct? So once all the things from 5 to be copied to 7, this connection will be ready. Right? 7 will also point out to 6. And after that, we have to update the connection of the next property of 5 also, because right now it is still pointing out to this. So we have to break this, and we have to point all the we have to point 5's next to this r to this current node. ऐसे ही होगा. So what will be the code? Like first thing, 7's next will having all the things which 5 is pointing. So 5's next, correct? Whatever 5's next is will be pointing out, will be copied to 7's next, correct? After that, this connection will be ready, right? Once this connection is ready, now we have to update the connections of 5 also, because right now 5 is also pointing out to 6, which is not correct, because 5 has to point to 7. So what we will do? 5's next is equal to 7. That's what we need to do, guys, for inserting a new element. But problem was not this. Problem was how we will reach to these two elements. Correct? Because we got two second position, right? And we only have one pointer head here. And this pointer will only be available at one node, not at two node. Correct? If this pointer is at this position, then we are okay. Then we can read the sixth node, because this node's next is 6. We know that. That's how Ekta has done it. So yeah, what was it? Ekta, right? Yeah, that's how Ekta has done it. And I think that's the same thing Likhit has also suggested in our last class. That's how we will start our loop of while. So we will start our loop from count is equal to 0. If we want to start from count is equal to 0, and then we will stop like we will increase one by one. So first time we will increase this head will be pointing out to here, and then we'll say like count is less than position minus 1. So this is our count. Position is 2. 2 minus 1, position is 2. Yeah, this condition, I think you guys have created this condition, right? So count would be 2. A count would be first time 0. Like this is our while loop, guys. Okay, this is our while loop, and this is our condition कि count जब तक position minus 1 से कम है, we will continuously move our head pointer. Correct? So that's what these guys done. So head is equal to head dot next and count plus plus. Correct? That's how you guys did it. You have started with count is equal to 0. Then you move to, then you checked first this condition. For in the first time, count would be 0. Position would be 2. 2 minus 1 would be 1. Yes, condition will pass. 0 is less than 1. Correct? So first time this condition will pass. You guys will go enter into it, and then you will move your head pointer to this position. Now head would be this place. Correct? And then in the next condition, now count will become 1, and 2 minus 1 is equal to 1. Now this condition will fail. So now you can see head is in the previous position. Where you have to insert? You have to insert it this position. So now you can get this position, and that would be next is equal to, or next node is equal to 5's next. 5's next. Correct? That's how, see, in the head node is pointing to 5, and now you have one more variable which is pointing out to X node. So you can see this is our next node. So that's what you guys did it. That's the one way to do that. Okay. First, let me know, did you guys understood this way? How Ekta and Likhit has suggested? Everyone understood this way? Let me know in the chat. Did you understood this way to reach the position? See, the concern is we need to reach these two positions, 5 and 6. Correct? We need to reach these two positions, because with the help of these two positions only, we can insert the new element. And I have showed you here. That's how you are inserting the next elements. Correct? So everyone understood? So there is so let's move into the next way. There is one more way. So last class you said go to the next value using temp. Why not changing the head value? Yes, Hariharan. We can do that also. We can take the head values in one variable and then move that one. That's a good practice. Okay. Okay, guys. So let's look for one more way to do that, and which would definitely help a lot of people in other questions also. In other questions also, that strategy will help you guys. Okay, and that strategy is we will start with pointer, two pointers in the starting only. So as Hariharan has reminded me, so let's take head into one variable, which is this dot head. Correct? And we will take one more pointer here, which is previous, and we will pointing out to null or anything. Okay, guys, we'll take the two pointers here. So let's see. Let's create a same nodes again. 3. We'll take the earlier nodes only. 4, 5, and 6. And here would be null. See, there's just the visualization. And count will, again, we will start from 0. Okay. Now I want to bring my current pointer to this node. So it will be very easy. So while count is less than position, just increment count plus plus, and current is equal to current dot next. Once you will do that, this loop will run and your current will be pointing out to this position. Because see, once the count is 0, it will be pointing out here. Once the count is 1, it will be pointing out here. Correct? And once the count is 2, it will be pointing out here. Right? 0, 1, 2. 1 minute. Let me see if anything. Because I think in the second condition, this loop will stop or not. 1 minute, guys. So it will be 0, it would be 1, it would be 2, right? Let's see. Our conditions is correct or not. So now count is 0 and position is 2, correct? So 0 less than 2, that's right. So now oh yeah, we are doing right. Our current will be at this place, correct? At 0th position. Now count is equal to 1. Now count is equal to 1. This current will be pointing out to this thing. Yes, we were right. Our condition is correct. Now current will be pointing out here. Now count has become 2 and our condition will stop. Correct, guys? So now we have reached to our current position where where we have to insert it. But now how to get the previous one? So for that, guys, what we will do, we'll take previous is equal to current. That's what we only need to do. So whenever we are moving our current pointer to the next one, previous will be on the previous one, on the previous node, because you can see we are moving our current to current dot next, but in the current variable is still on the fourth element. So that's why at that time we will assign this current to previous. So let's see, let's visualize it. Let's visualize it. So when count value is 0, our current was only here, right? Our current was here. Then we inserted into this loop and we made our count to 1, correct? Count plus plus, count become 1. Then what we did, previous is equal to current. It means right now previous is also going to point out to this one. Correct. Now we have done the previous equal to current. Now what we did in the third line, we have moved our current to next one. So now you can see this current has moved to this one. And now you can see previous is still here. Previous is still here. Then now count is equal to 1. Now for this loop, again count plus plus, count will become 2. Previous is equal to current. Now wherever the current pointer is, now previous will move there. So now this previous will be moving from here to this place. Correct, guys? And then our current variable will also, you can see the last line, current is equal to current dot next, and we will reach here with the current. Now you can see both pointer we have and our loop will be ended, and then we can do the same thing which we want to do here, right? So new node dot next is equal to previous next, and then previous next dot next is equal to new node. That's what, guys, we need to do. And you know, this way previous and current is going to help you in lot of places, in lot of problems where you want to find out the previous and next. This way will going to help you in many scenarios, many problems. This way is going to solve the problems. Then why to use current? So current could be, right now we are not using current, but current could also be useful. Understood? In this problem, current is not is not much relevant, but yes, in some problems, current could also be helpful to us. Okay, understood, everyone? So can you guys now code it? Can you guys now code it? So I will leave this part. So let's see in the in the same branch, guys. Today I've created one more branch, linked list 2, LL2. This is the branch LL2, and if you guys stuck anywhere, so you can see my single linked list second one. This is the original single linked list, and this is single linked list 2. So I have already created the whole method here. So if you go into the insert at, so you can see there the same thing which I did. I, rather than count, I have taken I have taken two variables, previous and current. While I was explaining you, I was explaining previous to null, but here I have taken into head. Doesn't matter, guys. You can take it as a null also. And then you can see the same code. Previous is equal to current, current is equal to current dot next. That's how we will move. And then you can see node dot next is equal to previous dot next, and previous dot next is equal to node. And then this dot length plus plus. Okay. Okay, guys. So that's how we'll insert into the any specific element. Correct. Let's see the next thing what we have in our operation. Yeah, so we have inserted at the index position. Okay, so next is, guys, get element at index. Get element at index. Yeah, doubt. Suraj, tell me, what is the doubt? What about Saturday class? Okay, we can talk about that doubt later, right? Let's continue our class. Okay. So guys, yeah. So next problem, next operation is for get element at an index position. Can you guys do that? Get element at index position, because now you do not need to go for previous or any next, previous or current. You just need to go for the current index and print the value, return the value from there. So like this, very quickly I will show you. So these are 4, this is 5, and this is 6, this is 7. Correct. Now it is pointing out to null, and this is pointing out to start. right? They are saying like, give me element at index 1. Give me element at index 1. 0, 1, 2, 3. You just need to do the similar thing. You just need to move this start element till here with the same condition while count less than index, and then current is equal to current dot next. So once current and count plus plus. So once count has become less than index, then you will stop your current variable at that place, and you have to do the console for this element, the value of that. So current dot value you have to return from there for this current pointer. Got it, guys? Yes, that's right. Okay, great. Let's move into the next one. Okay, and meanwhile, Suraj has said the doubt, so let's see. What is that doubt? Uh, so it's my repo you have shared. What is here? No, not this one. Not this one. If you want to see my code, you have to go to the LL2 branch, right? LL2 branch. And you have to go to the linked list. And you have to go for the, if you want to see the answer for the insert at position, so it's written here. So also written for get element also, if you want to see it. Okay. Got it, guys? Line number 33, okay. Line number 33. This dot length plus plus. This one. Oh, that is circular linked list. If you are sharing the circular linked list, we have not talked about circular linked list, right, Suraj? No need to look into that file right now. If you want to talk about that, we can talk about that later. It won't be relevant for others, right? Okay, no problem. So let's move further, guys. That's fine. That's fine. Okay. Okay, so let's move further, guys. What is next in our list? Okay, guys, now on the removing part, I think we have done all the insert operation. We have inserted from the front, we have inserted from the end, we have inserted into the middle. Is there any other positions left for insertion? No, right? Right. So let's not talk about the remove part. Remove from the start, remove from the end, remove from the middle. Right? Let's talk about that. Again, solving any problem in linked list, drawing is necessary. So we are going to talk about remove at start. Right? So let's see. Let's take the same example. 3, 4, 5, and then null. And this is a here head. Correct, guys? And now we want to remove this element. We want to remove it. Okay, that's fine. So you tell me, while removing this element, what are the changes will happen in the linked list? What are the changes will happen in this linked list? So the first change is head will be changed. Head will be changed. Head will be changed and pointing out to next element. Pointing out to next element. सबसे बड़ा change तो यही है. We have to move this head to this place now. Right? After removing it. Correct? I think that is the only big change we need to do, guys. Everyone, yes, length will also be changed. That's right. Length will also be changed. So length minus minus will happen there. Correct, guys? I think these two changes, if we will do that, I think we are good. So for that, what we will do, we will take this head pointer in one variable. Let current is equal to this dot head. So we now taken this head into one variable, correct? So now current is also pointing out here, right guys? And then what we did, the next thing, this dot head dot next, or might be not needed this, or might be what we can do, see what we can do now. So the next thing what we can do guys, we can simply uh, yeah, I think, see, the easy thing would be guys, just take the next element from the head, take the next element from this element. So see, 3 is pointing to 4, just take that thing, just take this element. If you will take this element, so we just need to make our head to this element. So let's see, no, let's take first head. This is our current element. Okay guys, this is our current element, this one. Okay, now what we need to do guys, this is our current element, and now this dot head should be pointing out to current dot next, right guys? Because see, this is current, what is current next is this element. So now our head should be pointing out to this element. So that's what we did in the second line. And then we need to delete our current element. So current is equal to null. This current, we will make it null. And then we will do the length minus minus. See, I can do this very easily also. I just need to do this thing, guys. If I do not want to these 3 lines, we can do this also. This dot head is equal to this dot head dot next. This dot head dot next, because that's what we did in these 2 lines. We have taken this dot head in current, and then we did taken the current dot next. But if we do not take the current, we can do directly this also, this dot head dot next. But I want to delete this memory, current is equal to null. So that's why I have taken it into one variable. Let current is equal to this dot head, then current next. Now the current next will be pointed out by this dot head, and then current is equal to null. Then make that element deleted. Now this element will be deleted, and length minus minus. Understood guys? Whatever we understood in the visualization, same thing is happening there, correct? Iska next, that would be our head, after deleting this 3, the next of 3 will be our new head. So that's what we did. We have taken this dot head into current. So current next is our new head. So this dot head is equal to current next, and then current is equal to null. So it means delete all the memory of current, because this current has 2 properties, right? Value, address. We have and we did current is equal to null, and length minus minus. Understood, guys? Remove and start. Sir, is it must current is equal to null? Yes, it's good practice to make to free all the memories which current was holding. Current was holding 2 things, right? Every node is holding 2 things: value and address, value and next, 2 properties. We just made it free. Can you show how the second approach would work? The same way. This is our second approach. Vishal, this is our second approach. So see, this dot head dot next, it means this dot head, this is our head currently pointing out. Iska next, what would be the next of this? 4 only. So iska next will point out to head. So this dot head is equal to this dot head dot next. These 2 lines can be written like this. This dot head is equal to this dot head dot next. Wanted to make duplicate. No, it won't. Why would it make duplicate? Because Head dot next is only pointing out to 4. What is, see, when we will do this dot head, it will give us 3 and next, correct? And when we did this dot head dot next, it will give us this one, right? This dot head dot next, which is pointing out to 4, right? If we do this dot head dot next, it will give us 4 dot next, this property. So what we did, we made all these through this dot head. Now this dot head is updated. Now this dot head is pointing to 4. That's what is happening here in the second approach. Understood, Vishal? Yeah, it won't. Okay, so this was the remove at start. So let me show you quickly the code also, guys. So I'm saying if we do not have head, this is like the condition where we do not have head. So we are simply returning false. Or if we had head, so just take it in one variable, take the next of it into the head, remove node is equal to null, this dot length minus minus, return this to print list. Whatever we discussed in the first approach, did the similar thing in code, right? Now let's jump into the second scenario where we want to remove from the end. Remove at end. So two ways, right guys? If somebody wants to remove things from the linked list, we always have two ways, right? Let's again draw it. 4, 5, 6, and null. And this is our start. Let's talk the first way, which is with the help of tail. With the help of tail. Ab dekho, tail will be pointing out here, right? And we want to delete this one. Correct, guys? Tail will be pointing out to here, and we want to delete it. We want to delete it. So see, now we need to somehow again reach to previous. Now you can see, guys. Now you guys can see everyone, Likhit or somebody else who must be confusing, who must be earlier confusing why we are using the previous and the current. Now you can see in this scenario again we need to reach the previous. Otherwise we cannot delete the last one. Is there any way if we do not reach the previous we can delete our last element? No, right? We have to reach the previous, and that's what the same rule will be applied here. While current, we have to do current is equal to current dot next, and previous is equal to current. Same rule, and this while loop will only end it when we will get the null. So you can see every time I'm doing current is equal to current dot next. So when current will reach here, the current dot next will be null. So now current will be having null, and then at that place condition will stop and previous will be at this place. And then we need to do the similar thing, guys. We can take this previous in one variable. Already is previous in a variable, so no need to do that. So what we need to do, previous dot next is equal to null, because now this is our new end. Now this this element will be deleted. Now this previous will be pointing out to null. So first we need to do previous dot next is equal to null, and then current is equal to null. So all the memory of current will also be deleted, right? And then we can update our tail also. This dot tail is equal to previous. Now our tail will be pointing out to this one. Is it not easy, guys? Right, guys? Is it not easy? We just move to till the last. We already have the previous position. Just do the previous dot next is equal to null, and then free the memory of current variable. And again, yeah, this dot length minus minus. Do not forget that one also. This dot length minus minus. See, that's all. That's how we do the things here. Let me show you the code also. You see, similar way, we reach to the previous and current. As we read the previous component, first we did the remove node is equal to null, which is our current element. We do not need this also, like, I think this line is also not needed. We can simply do current is equal to null. Current is equal to null. And then you can see previous dot next is equal to null. This dot tail is equal to previous, because now tail will become previous. This previous element will become tail. You can see, you can visualize it. See, visualization is very important. Now this previous will become tail. So now that's what we did in the code also. This dot tail is equal to previous, and this dot length minus minus. Print list. Are you feeling confident, guys? I already told you in the first class, it's all visualization. Linked list is full on visualization. Whatever you are visualizing while in the diagram, that's how you need to read the code. That's how you need to read the code. That's how you need to write the code, sorry. Okay, I have written while current dot next. Let's see. While current dot next. Yeah, this will not work, I think. Yeah. Let me see. While current dot next is equal to null. So it would be, so when current would be here at this place, so current dot next, so current would be here, current dot next would be null. Yeah, I think this will not, this will, I think this could like throw error, I believe, because see what is happening here. Let's see through the, let's understand this with the pointer. We can only understand everything from the pointers. Let's see. Okay. So see, first time we are checking current dot next. Current dot next is equal to null. Is it not? Which is not, क्योंकि current के next में 4 है. Okay. So we'll move our current here, and this would be our previous. Correct, guys? Right? Then again, current dot next is equal to null. No. So we'll move our current again to the further here, and we'll move our previous to here. Correct? Now our current has become null, right? And then we are checking null dot next. Null dot next. So I believe this could give us error. This could give us error, or we might go, if you want to really do that, I think current would be good. Current would be good. Okay, Ariran? Current would be good. With current dot next, you can see, right? Once we were in the second loop, at that time we have already made current to null, and then in the condition we are going to check null dot next. So that would be problematic. Current is good there. Okay. Let's see the third scenario. I think we have deleted from the starting, we have deleted from the end. Now it's time for delete from the middle position, any other position. Same like insertion. Again, let's read. Remove from middle, or remove from any index. Remove from index. Same scenario. Like again, 4, 5, 6, 7. This is null. This is our start. And we want to delete it, the second index, which is 0, 1, 2, 3. We want to delete this one. Correct, guys? We want to delete this one. Again, we need to reach to the previous or current. Again, we need to reach to this one as a previous and this one as a current. Do I need to read the, do I need to write the code for previous and current again? We can do that, right? Previous and current, we can do that easily. With the count one, right? We'll take count is equal to 0. Same like as insertion, we can reach there. So once we reach it there, then we need to think. So now what we need to do? We need to break this connection and we need to make this connection now. Correct, guys? We need to break this connection 5 to 6, and we also need to break this one. We need to break these two connections, and we need to make like this connection now, because this element has to be removed. So what will happen here? So now previous dot next is previous not next is equal to current dot next. So current का next ये है, so we will update, we'll copy this current dot next to previous dot next, ये connection बन जाएगा, correct? And then current is equal to null. I think that's all done. This dot length minus minus. That's all. That's all. Is it not easy, guys? Just repeating everything. Why current to null? Yeah, current to null we are doing Likhit just to free our memory, because we know that each node has two things, well and next, right? And that next is pointing out to many nodes. So we are just freeing this memory and we are keeping at that position null. So this all will be cleared it out from that node. Understood? What about other questions? Somebody was asking current is equal to null. Joseph was also asking, I answered it. Hariharan, please repeat, sir. Okay. Okay. So Hariharan, we have understood this thing, right? How to reach previous and current. Correct. So once we reach to the previous and we have the current pointers, we need to remove this node, right? And this node is making connection with previous node also or next node also, which was this one 7. Correct. That's how these two connections are made here. Agree? These two connections were there, and we need to break this connection. Now 5 should be pointing out to 7. Then only 6 will be deleted. So what we did, first we have taken this connection. What is this connection? This connection is this one, current dot next. This connection is current dot next, and we have to make this connection to, we have to copy this connection to the previous node, because now 5 will be connecting to 7. So that's what we did. Previous dot next. Pehle previous dot next was pointing out to 6. Now previous node next will be pointing out to this one. And then how we will get this connection? We will from the current. So current dot next we have assigned into the previous dot next. Understood? Now this previous dot next is pointing to 7. And how we will get the 7? We'll get from the current. So current dot next is 7. Understood? Yeah, great. I will show you quickly the code also. This is same. If position is 0, remove at start. Position is this dot length, remove at end. You see, previous and current one. Then the code previous dot next is equal to current dot next. Current is equal to null, this dot length. Return this dot print list. Okay, guys. That was simple. Single link list operations. And guys, these are very easy operations, right? And I have seen in the interviews, I think that this is all linked list, single linked list. That was all single linked list, which we can talk about here. That was all. Okay, you want me to run also? That's great. Let's run it. So let's close all the methods here. And we have corrected, right, that current one which Hariharan was pointing out. This one's that, right? We have corrected that current dot next. Okay. So let's see. So we are doing prepend 4, 5, 6. So how this will look like? This will look like this, guys. We are doing prepend. So first time we have inserted 4. Then we did 5 prepend. Then we did 6 prepend. Now it's start here and tail here. This will be pointing out to null. Correct? And we did append also. Append 8. So it means we inserted at the end also. 8. Then is there any other? Yeah, we have inserted at the third index. 0, 1, 2, 3. Means at the end it seems like. Let me quickly see the insert at code. We are taking what? Yeah, I is equal to 0. Yeah, looks good. We are inserting at this position. So 9 and 8. Correct? Now, let's print it out first, these things. That the append and insertion are working properly or not. And yeah, get element index 3 also. That's fine. Let's print it out. Okay. So we will see that. So node linked list single ll2.js. We will see only the last one. See, get element index is also giving us. Okay, that's fine. It is giving us what? It is giving us console like okay, that's fine. And I think last one is before that insert at. So insert as I'm sure, yeah, it is returning the print list. Okay, we have to see only the last one. Okay, we can see the last one only. That's what I was saying. 6, 5, 4, 9, 8. We can see 6, 5, 4, 9, 8. And you can see at the third index, we are getting 9. And this is our whole linked list, which I consoled it out at the end. You see, console.top linked list. Starting head is at 6 position, tail is at 8 position, and length is 5. Looks good, guys? Let's remove it now. Let's remove first from the end. Now we are removing end. It means 8 would be deleted. 8 would be deleted. Now 9 should be our tail, and the last printing should be 6549. Let's see that. So remove at end is pointing out to 8 also, 8 only. Okay, so remove at end didn't work, guys. So let's see. Okay, so we are while current, previous is equal to current, current is equal to current dot next, right? And this one we have corrected also, right? 1 minute. This one only we have corrected, right, guys? Hariharan, this one only you were telling me, right? Okay, let's see. This one is not working, looks like. So remove at end, previous at this place, current as this dot head. Okay, current, previous current, current is equal to current dot next. Let's debug it. Okay, quickly. 1 minute. Start debugging. 4664. It is still debugging which file? Oh, CLL. No. Debug this current file. Start debugging. It is going to CLL only. Okay, let's remove it. Might be possible. That's why it is taking the first one. Oh no, it is taking again that file. Okay, I'm trying to debug this one. 1 minute. That's why I use very less these debuggers here. But I'm like trying to look, is there anyone? Run current file. Yeah, run current file is there. Run current file. Oh yeah, we are at the current file. We can see now. So see, in the head, we can see the, yeah, 6 is coming. We can see in the head, yeah, 6 is coming. That looks good. And in the previous, it will see the 6 would be there, and the current will still be same right now because previous and current are same place. Let's move ahead. Okay, now let's look into the current. Now current is as 5 because current has moved to this one. Now current has moved to this one, right? Let's move further. Okay, okay. What is right now current? It should be 9, right? We are at the this one, last one. Current is 9. Now let's move further. Now you will see previous and current would be both 9. Now after this line, current would be at 8, right? current would be at 8. It would be at the last point, this one. That's what I was expecting. Current should be here. Now you can see previous will be at the previous would be at the current only. Oh, okay, okay. That is the problem actually, guys. Yes, yes, yes. Okay, okay, okay. Actually, you know, we have to stop at previous one. Yes, that was the problem actually. We have to stop at the previous one. I think that's why I have written the condition correctly. Yeah, I think the condition with which we were talking about here is not, it's not running in that way which we were expecting. Because you see, when the current will be 8 or when the current would be this place, previous will also be got updated, right? See, what happened again, let's explain it. What was happening there? 4, 5 and 6, correct? So we have started from here. This was our current, correct? Then we move to this one, right? In our while condition. While we are moving in this condition, previous is also there. Then we made the previous also here, correct? Then we are moving our current to this place, last one. Then our previous also come to this place, according to the conditions which we have written. And then our current gone to null. So that was the problem, guys. That was the problem was happening. That's why I think I need to stop at current dot next only. When the current dot next is equal to not null, then now you will see that previous will not go further and current dot next will also not there. Now let's run our code. Let us stop debugger. Let's run our code now. You see now 6549 and tail f is equal to 9. That was, this one got deleted and tail moved to 9. Understood? So yes, Hariram, that was right. I have explained that one little. The condition wise, I have explained a little bit wrong to you. Okay, let me explain you again. What happened? What condition we have written? That condition was we have to stop our while loop when our current is at null position. And then inside the loop, what we were doing, we were moving our previous also to current, right? Previous to current, and current is equal to current dot next. Correct. So see, due to that, so we what is happening when current is at the last position, this one, at this position. So now previous will also be at this position. That's how we are moving our cursors. So somehow we need to write a code in this way that when the current at this place, the previous should be here. Previous should be here. And then how will this happen? So when the previous at this place, at that time we only need to check current is equal to current dot next. So जब भी इसका current का whatever the current next is going to be null, at that time we will not go inside this loop. We will not go inside this loop. Let's run it. Let's run it from the starting. Then I think we will understand better. Okay. So let's see. We'll start from start point. See, it's fine. Actually, with visualization only we can understand how the code is running with this scenario. So let's see. First time start here, previous at null position or any position, doesn't matter. Okay. Let's move now further. So current is not null. Yes, current is not null. Previous is equal to current. Yes, previous is also started pointing out here. Then current is equal to current dot next. Now this current is pointing out here. Correct, guys? Now second iteration. Second iteration. Current is not null. Yes, current is not null. Make our previous here. Now this previous will move here. And this line, which will be running, will moving our current to here. Right, guys? Next line. Next again, previous is equal to current. Now this previous will be moved here, right? And current will be moved here. Correct? That's how the loop is working. Again, current is not null, no. Move our current to this place and previous to this place. This is where I should stop now. This is where I should stop now. But what I did with this condition, what I did, if current is not null, still go it one more time. Still go one more time and then do the current dot next. That was wrong I did. I should be stopping here. And how can I stop here? I should check here current dot next. Current dot next. If current dot next is null, I will be stopping here. Yes, current dot next is null. I should stop here. Now my previous should be here and current should be here. Understood? That's what the error was. So yeah, so remove at end was working now. Now let's check for remove at also. So we are looking for remove at second position. So second position would be after removing 8, the second position would be 6, 5, 4, 9. This is our linked list right now. So 0, 1, 2. So 4 would be deleted. So let's see. Yes, 6, 5, 9. 6, 5, 9. Only 3 elements are coming. Okay. Okay, everyone. Now whole code is running. Let me push these changes also. So this would be for everyone. I think the earlier code is already correct. So single linked list 2, earlier code is, let me see if any changes we did. Oh yeah, this one we did. Current is equal to null. Okay, let me push this change. And in CLL, what changes I did? That is not for now. Let me push it by the way. No problem. Give st, get add, commit -m. Okay, that was all about the single linked list, guys. Okay, after that, there will be a lot of problems will come to you, like rotation of single linked list, reverse the linked list. A lot of problem will be there for single linked list. Okay, which we will looking into our next classes might be. Okay, so now let's jump into the double linked list also. Everything is same. Everything in all the operation in double linked list are same. Just 2 or 3 operations are there where double linked list will provide you extra benefit, because you see in while removing any see wherever you use the previous, you do not need to use that, because in the double linked list everywhere previous is available. With each node previous is available. So that's why everywhere every code which you written in a single linked list is same as double linked list. Every operations, everything is same. It just some of the operation will become more easy for you, like the this one, remove at index, the last one which we did, remove at index. In that place you have to go to the previous and next element, right? Here you do not need to go to that place. You already know that the previous is already there in that node. You just need to reach to that node, and that node already has the previous and next pointer. But let's see quickly. But did you get this point? What I'm trying to say here, that wherever we are trying to look right now for previous pointer, that won't be needed in that double linked list, because every node has previous pointer. So that's only one difference only. Other than that, everything is same. Every line of code is same. Okay, let's quickly see that. Yeah. So according to slide, I think we have done everything in a single linked list. Deleting node at index. Yeah, double linked list. So as we know that in double linked list, data has sorry, not data. Node has 3 properties: value, next, and previous. Correct, guys? So first we will create these 3 only. So how we will create? Class double linked list. We'll write our constructor as we did in the previous class, which will take value from the outside, and it will give us three properties to us. This dot value is equal to val. This dot previous is equal to null. By default, all the pointer will be null. All the properties, this would be null, this would be null, and value which we are providing, like 4 or 5, and then this will also have this dot next is equal to null. Understood? That's how we'll create the node, right? This would be node only, not the linked list. This is not doubly linked list. It's just the doubly linked list node. Understood, guys? Are we good with double linked list node? Same, right? Earlier than that, just add one more property on that. Correct? So let's see. Let me show you in the code also. The same thing which I written. You see, double linked list node, constructor, value, previous, next. Earlier in the single linked list, if you remember, we only has two properties, this dot data and next. Previous was not there. Okay, right, guys? That's what the same thing. Now, now let's talk about the linked list. Linked list will also have the similar like by default similar properties. Double linked list will also have by default single properties. If you want to take tail, we'll take it. Otherwise, you can ignore it also. Guys, one thing one thing, let me clear it. Here, in some of the examples, you might not able to see tail. You might not able to see tail because I told you, right, for finding out the end element, there are two ways. You can use the tail pointer. Otherwise, if you do not want to use the tail pointer, you can go without tail pointer also. You have to find out the end element. You have to just go current dot next is equal to null. That would be our end element. Right, guys? Understood? Understood? We can use tail or we can not use tail. In the examples of slide, if you want to see the examples of slide, you will see they are not, if while they are creating the double linked list, they have not used the tail. Same for single linked list. They have not used the tail. They are only going with head. So, but yes, it's not, you are also agreeing with that, right? We do not need tail, right? We can simply do the operations, all the operations without tail variables also. Are you guys getting it this point or not? Because there would be after this class, there will be a lot of examples in the internet. You will be seeing it, and at that time you will see that tail is not there. You will see like like Arpit has taught me that tail will be there, tail should be there. So that's why I'm clearing this thing. That's why I'm clearing this thing. Tail is not that much important because the tail, whatever the tail is answering us, we can get it from another way also, and that is reach the end element. And how we will reach the element? Wherever the next is null, that is end element. Okay. Yes, and head reference will be provided everywhere. Yes, head reference they will provide in every problem. In lead code, if you will go, there are every problem they are not providing head tail anywhere. They are everywhere providing the head pointer to you. Okay, guys. Okay, so let's see if we have double linked list, how we will do the prepend operation. What would be our prepend operation? Prepend means insert at start. Prepend means insert at start. अब देखो, say two scenarios for prepend. Again, similar like single linked list. The single linked list was also two scenarios. If head is present, if there is any element in head, so what? And if not, so what? Right? If head is not empty, if there is no element in the linked list, that scenario, no element in linked list, or element in linked list, element in linked list. Two scenarios. Same scenarios we did in single linked list also, right? You remember, right? When we were doing the prepend. Everyone, do you guys remember that one? Similar thing will happen here. Similar, guys. No change. So the first condition is same. If this dot head we are taking, right, not host. If this dot head is equal to null, what we did earlier there, we'll create the new element. So first, always create a new element, new node, and we'll just point this dot head to new node, or this dot tail also to new node. And then we'll do the this dot length is equal to length plus plus. Same thing. Same thing, guys. Same thing will happen. These 3 lines we have written in the single linked list also. 3 lines we have written in the single linked list also. Okay? You can see in the single linked list also. While we are doing the prepend, when the head is null, you can see same line we have written here. Right? And then in the single double linked list, there might be one extra line which is not relevant, I think. But now, all 4 lines, same lines. Understood, guys? Same lines are there. Now let's see the second scenario. Second scenario is also same. If there is any element, let's draw it. Let's draw it. Everywhere actually both are same. So 4, which would be pointing out to 5. See, diagram will be changed now because we have previous and next. And 6, which will be pointing out to this, and then will be pointing out to null. And this would be our head. And for head, always the previous element also point out to null. Previous element always point out to null. Understood this diagram? Can you guys understood this diagram? If you understood this diagram, you understood double linked list. Because this diagram is only the solution to everything. If you understood this diagram, that's how the double linked list look like. That's how you need to do all the operations. Understood? Now we want to insert a new element 3, which is pointing out to null, like by default null, next also null, because that's how we created a new element. That's how we create the new element. Next is pointing out to null, previous also pointing out to null. Now we want to insert this element at first position. So what we will do, same thing, let current. अब देखो यहां पर ना प्रीवियस को और देखना पड़ेगा बस. पहले हम इन द सिंगल लिंक लिस्ट वी वर ओनली टेकिंग केयर ऑफ नेक्स्ट. We were only taking care of next, but in this double linked list we also have to take care of previous now. Okay, see, double linked list is providing some additional benefits to you. At the end there is a list where we will see the differences between all these three, some of the features which are extra available in the double linked list. You see now, in a single linked list you are only going through the one directions, but in the double linked list you can go bi-directional. You can go from any node to previous also, and also to the next side. Any direction you can go in the double linked list. So when you have scenarios like this where you want to go from any node to any direction, you will go with double linked list. But you do not have any scenarios like that, you will go with the single linked list. In similar ways goes for the circular linked list also. If you want to like rotate everything in one circle way, then you will go with the circular linked list. If you don't want any end, you have any data use cases where you do not want any end, you will just go into the circle ways. Okay, so let's see this one. So first let's take our current to one, let's take our head to our one current variable. So now current is also pointing out to here. Let's take it from another color. Current is also pointing out to this. Now what we need to do, first we need to update the next of this. न्यू का नेक्स्ट हमें अपडेट करना है. सो दैट्स व्हाट विल डू दैट. सो न्यू नोड नेक्स्ट is equal to what? You guys tell me. New node next is equal to what? You see this and you guys tell me what would be the next of this. We want to insert it before it. We want to insert it before it, before this 4. current. Correct. So new node dot next is equal to current. So now you can see this connection has been made. Now you can see this connection has been made from this side only. From this side. From this side, not from this side. Fourth previous is still pointing out to null. So for that, what we will do? Current dot previous is equal to new node. That's what, guys. In the double linked list, you also have to think about the previous. You also have to think about the previous. Understood this line? Current node dot previous is equal to new node. Understood? Current node dot previous equal to new node. अब देखो connection proper बन चुका है. Now this connection like this and like this has been. Let me erase it and write it clearly. So earlier it was pointing out to null earlier, but now after writing these two lines, connection is made like this, u or u. Now what is the next one? What is the next? What is the one thing is still left? Which is length plus plus. Okay, length plus plus is still one line is there, which is still missing. Yes, head will point out to now this node. So that's what this dot head is equal to new node. Because you can see na, abhi head yahan par hai. We don't want head this place. We want head this place. So now our head will pointing out to here. This dot head. That's what the code is, guys. Earlier code is similar. It just we need to take care of previous this time. So what we did, new node dot next is equal to this dot head, and this dot head is equal to new node. I think we are missing one line here, which is this one. Current dot previous is equal to new node, which is missing here. So which we could do before that, I think. Yeah, well, let's take it. Let current is equal to this dot head, right? Unless new node dot next is equal to this dot head, yeah, current. Then current dot previous is equal to new node. Right, guys? Am I doing anything wrong? Correct, guys? We have written the right step. Correct? Let's look into the code here if you are doing anything wrong. Yeah, insert at start. New node dot previous is equal to null. Already our new node is null, so we do not need to take this thing. And yeah, if this dot head is not equal to null, if this dot head is not equal to null, then they are only doing this dot head dot previous is equal to new node. Not sure, but our code will work, right? Let's run it. Let's run it and let's check it. Yeah. So we are doing 4, 5, 6 again similar. So our output should look like this. Our output should look like this. First 4 would be inserted, then 5, then 6, and our start should be here, and our end should be here. It should be here. Let's look into it. We already printing it out also. So let's run it. Node linked list single linked list 2. Oh, it is single linked list. Oh, we were looking into single single linked list. We made the changes in single linked list. Oh. Oh yeah, we made the changes in single linked list. Oh, this is a double linked list, no? Sorry for that, guys. Oh yeah, here we were doing it, right? Yeah, that's what I said. That's why actually I got confused. Why it was not there? Oh, sorry, sorry. I missed that comment of yours. Thank you, Ariran. Thank you. That's why actually I got confused. Why these lines are missing there? Okay, so that was, guys, inside at the start. Okay, now let's look into the inside at end. Now let's look into the inside at end. That would also be same, guys. I know you guys can now do it. 6. Same example we'll take. This time just little bit bigger. Pointing out to null, pointing out to 5, pointing back to 6, pointing to 4, pointing back to 5, pointing back to null. Correct? That is how the double linked list look like. Head is here. And if we have tail, then fine. If we do not have tail, then also it's fine. So now we want to insert it at this place. Right, guys? So if we have tail, we can easily do that. If we have tail, we can easily do that. So we can take 7. That's what we want to insert it. Right? 7 has null is here and here also null. Correct? That's how we create the new node. Agree, guys? That's how. Now what we need to do? We need to first make this connection. I think, yeah, only this connection has to make. Only this connection has to make, and we need to update our tail. That's how. That's what we need to do only. So what we need to do? We'll take our tail into one variable, current, this dot tail, and then current node dot previous. Current node dot previous is equal to current, which is this one, dot next. So जो भी current के next में है वो यहाँ पे आएगा. और now back connection also. Now back connection. So now current node dot next equal to this one, which is new node. You see, every time I'm making the both connections. Every time I'm making the both connections. Not like that we are only making one connection. We're always making first this connection like this, then we are making this connection also. So that's what previous and next, and this one is already null, so we do not need to make any connection here. And at the end we'll do this dot tail is equal to new node, and this dot length minus minus. Correct, guys? Or otherwise, if we do not have tail, so what we will do? We'll run one loop for current dot next. Or this time I think we can stop in current also. In this scenario, we can take current also, because we will stop at current only. Right? We can take this time also current also. Current is equal to current dot next. We can stop we'll stop at current only. No. This will again give us null. You know that? This will again give us null. No. This condition is not correct. Yeah, I think this condition is unlock fine. Current dot next. Every time remember, for traversing, I think this condition is better, I think. While current dot next, it will stop at current position. Correct? Yeah, this will stop at current position, correct? Here. And then we can, once we got this position, we can follow the same loop like this. Understood? Both scenarios? Line number 2, why current node dot previous equal to current dot next? It should be current node dot previous equal to current, right? 1 minute. Current node dot previous, current node. Oh, okay. This is not current node, guys. This is new node. First thing, this is new node. I'm talking about this one, right? New node dot previous. New node dot previous is equal to current dot next. Yeah. Oh, okay, okay. Yes, yes, yes. 1 minute, 1 minute. No, no, no. Actually, we are correct, right? So we are making this connection. So here, this node should come. Okay. So new node dot previous is equal to current. Oh, yes, yes, yes. Because current node dot next is null. Oh, yes. This is the code. Right, right, right. Now understood? Current dot next is equal to new node. Yeah, which is here. This line. Current dot next is equal to new node. We can go for break now, guys. But yeah, let's quickly see this code also in double linked list. So we are using tail. So node dot previous is equal to temp. That's what new node dot previous is equal to current, which is temp we have taken. Temp dot next is equal to node, and this dot tail is equal to node. Okay, looks good. Looks good, right? Let's go for break and then come back and then continue our discussion on this one. Okay, let's go for 15-minute break. So we'll come back at 10 o'clock. 15-minute timer. Is everyone back? Oh, that is alarm also. So yeah, is everyone back now? You guys can hear me? Okay, guys. So let's see two more scenarios in double linked list, which are insertion at middle index and then remove at the middle index. Other than that, I think you guys can do it at your own, right? Because all the operations are similar to single linked list. So we'll not spend more time on double linked list. So we will quickly understand the scenarios of insertion at index, and same will go for the remove else. Okay. So yeah, so let's take the same example, this one. Quickly clear it out. Because double linked list is very easy if you know the single linked list. In the circular linked list, there are some complexities which we will see. Okay. So we can create one more element here, 6. We're pointing out to null and like this. You guys are able to see my screen, right? Okay, great. So we want to insert one element 4 in the middle of this position, like at the second position, second index. And how will you reach to second index? We already know that, correct? That how to reach the second index. Let's create one more actually, because this looks like the end element. So let's create one more element here. Rather than pointing out to null, or it's okay if it is pointing out to null also, that's fine. That's fine. Let's consider this scenario where we do not have tail, right? Okay, so now guys, what we need to do here, we need to first break this connection. We also need to break this connection. We need to break these two connections, right guys? And then how many new connection we need to create? We need to create 4 new connection. First from here to here, right? Second from here to here, right? Then next from here to here, and then from here to here. Correct, guys? 4 we need to break. 4 we need to create. 4 connection we need to create. Right, guys? Everyone agrees with that? Let me know in the chat. Right? We need to make the 4 connections. So let's start from first connection for new node. This is a new node. So first create this connection. So let's see. New node. Okay, before that, before that, before that, we are at this element, right? Current, right? With the while loop, we will be here in this node, right? So let's take from here. Let previous first take the previous node from here. So let previous is equal to current dot previous. Correct. So now previous will be at this pointer, at this node, right? Right, guys? So we got the previous, we got the current here, right? So now let's update this one. So first thing, so new node dot next equal to current. Agree, guys? New node dot next equal to current. Agree, guys, with the new node dot next? Are we good with there? Yes. Now, current dot previous. Should we break it right now? Yeah, I think we can break it. No need current dot previous. We already have taken the current dot previous. Yes, We can break it now. So now current dot previous is equal to new node. So now this connection has been broken. This connection has been broken. Now this new node is pointing out to, now this has been become permanent connection. Correct guys? Now this connection has been permanent. Now time for this one on the left side. So let's start from, let's first update this one. So new node dot previous is equal to previous node. Right guys? The whole previous node will be here. Now this connection is ready. This connection, now we need to make this one, last one, which is previous dot next equal to new node. It's done guys. And then this dot length plus plus. See how easy it becomes with this diagrams. How easy it has become with this diagram. Agree guys? Current dot previous. We have taken current dot previous. Yeah, this one. This one, Joseph. Current dot previous. This pointer. I'm talking about this pointer. Current dot previous. Okay. Yeah. Now let's move. Let's talk about. Now let's talk about the delete scenario. Okay. Now let's quickly talk about the delete scenarios also. 6, 5, 4. Right. Pointing out to null. This connection. This connection. This has this connection. This has this connection, right? And it is pointing out to null. Here we have head. Okay, that's it. Now we want to delete this one. Now we want to delete this one. So now what we need to do, you can understand. Now with this diagram only we need to understand. So see, after deleting this thing, this pointer, this one, this has to point to this one, right? This pointer has to point to this one, and same goes for this one also. This has to point to this one. So only two connections I think we need to make here, right guys? Only two connections we need to make here, right? So first we'll reach to this position, like same with the count, with the same count logic. We'll read to one index, which will be here current, right guys? Now what we need to do, how we will get this element from here, from the previous we'll get this element, from the next we'll get this one, right? So let's take all the elements. Let previous is equal to current dot previous. So this will give us this one, current dot previous. Let next equal to current dot next, right? Now we got this one also. Now we just need to make connections. So now let's see. In the previous dot next, इसके next में ये connection बनाते हैं पहले. Make this connection. Okay. So the previous dot next equal to next. I think previous dot next is equal to next. Next element, this one. Okay, this one take some other name. Otherwise, next will be confused. Or let next element, next node on this would be previous node. Yeah. So previous dot next is equal to next node. So now this connection is ready. Again, now once this connection is ready, we need to make this connection also, which would be next node dot previous is equal to previous node. And then current is equal to null. Why we are doing it? Already told you, to clear out the memories. You can understand that double linked list takes more memory than the single linked list, because in one node we are storing now 2 pointers, and then this dot length minus minus. Understood, guys? How we will do the remove point? In line number in line number 2, it not new node dot next is equal to current dot previous. In line number 2, this one, right? You are saying above one, this one. You are telling about the previous scenario here. Yeah, insertion. Line number 2, this one you are talking about. New node not next is equal to current dot previous. Okay, let's see. So new node new node dot next is equal to, so new node dot next is equal to current dot previous. No, it will not. So the current dot previous will be this. Current dot Joseph, current dot previous will be this element, right? So we do not want to keep this element here. So we want to keep this whole current element here. So that's why new node dot next equal to current. Current dot previous will give us this one. Understood, Joseph? So that's why we will not do the current dot previous. Got it? Okay. So I think that's all, guys, for the double linked list. Okay. And I want you guys to now do the other operations like insert at end. I think we already done that. Insert at index, we already done it. Get element, similar like get element will work also. Right? Remove at start, remove at end. It's same, right? Now let's jump into the circular linked list. That is little bit complicated to understand. Okay, but yes, again with a diagram we'll try to understand it, try to make it easy. Okay, with the diagram, because without diagram very difficult to understand linked list. Okay, guys, so let's talk about the circular linked list. Or I think I have already pushed, like I have already had all the methods. If you guys got anywhere confused, you guys can see my code here. Remove at start, remove at end, remove at, already written everything. Okay, now let's jump into the CLL part, which is circular linked list, which has very many examples, very much applications. Circular linked list, like stack and queue. All the operations of stack and queue we could do with a circular linked list, because in the stack and queues, you know, right? In the queues, insert from the end side and goes from the front side. So circular linked list could help you. So guys, let's see here in the circular linked list, as we were explaining you, all the elements, all the nodes will be pointing out to the next element, and the last element will not pointing out to null. This time it will be pointing out to the first element. It will be pointing out to the first element, right? Circular also will have previous and next. So that depend on if you are trying to create circular double linked list. If you are trying to create circular double linked list, then you see circular is nothing. Circular linked list is not a new type. Circular is a new idea. Circular linked list is a new idea for existing linked list. There are single linked list, double linked list. They both are working in different ways. Circular linked list is a new idea, which is telling, rather than pointing last element to null, point it out to the point out to the start element. That's the idea, and you can implement this idea in both linked list, double linked list also and single linked list also. But here we are going to look with a single linked list. Okay, Hariharan? So see, so this is the node 4, which is pointing out to 5, which is pointing out to 6, and then this 6 is pointing out back to 4. This 6 is pointing out back to 4. Now that is circular linked list, guys. That's what the circular linked list is. That is what the circular link list. So guys, here we just need head pointer or might be tail pointer, but we do not need both pointers. We do not need both pointers because with one pointer we can do both works, right? And it would be better if we take the tail pointer. If we take the tail pointer, because always the next element of tail would be head. So if we want to like create the head, we just need to do let head is equal to this dot tail dot next. But if we will take the head, we will not we will never get the tail. If we get the head in single linked list, are you, are we will able, are we will able to get the tail pointer if we will pointing out our head here? We won't, right? So that's why the better practice is some people are taking both scenarios. It's not like that they are just simply taking the head. But I think if you will take the tail, I think you will get little bit extra features, little bit extra feature because see you all now you have commands on two things. You have if you are taking tail as your pointer for your circular linked list, you have commands on two things. First thing at tail, that wherever the tail pointer you will keep, that will always be your last element, and then the next element of that will always be head, right guys? So I see why what I'm telling here, it could be little bit confused for you, but yes, I'm telling you you can take head and tail both in the circular linked list scenarios. But taking tail will give you some extra advantages, which is like wherever the pointed tail is, that will give you the that will give you the last element in the linked list, last element in the linked list, right, guys? And whenever you will do tail dot next, whatever element is coming after tail, that will always be your head or start or the first element. So now with one pointer you are able to get both scenarios, you are able to do both scenarios, like in the queues, like in the queue you need two pointers, you need two places in queue. From one place you can insert and from another place you can go out. So with one pointer you can achieve both, right? Whenever somebody is saying they want to insert it, so you will go for they want to insert it from the end, like you will always use this dot tail. If you know little bit about the queue, in the queue we enter into from the end side and go from the outside, like in the cinema hall. I'm just telling you one example of circular linked list only with the queue. So in the queue, if we talk about the ticket counter, so in the ticket counter, how we create the lines? Lines are queue. So whenever five people are standing in the line, we enter at the end, and then whoever is coming at the first, that person will get the ticket. That's how the queue works. That's how the queue works. In queue, we insert from the back, or enter from the back, and then we go out from the starting. We go out from the starting. So with a circular linked list, we can achieve it. With this dot tail, whenever somebody wants to insert it, we will insert it at the this dot tail position. We'll always take the we will insert, like we will always do the append, like insert at the end, always do the append. And when somebody wants to go out, we will take this dot tail dot next. That would be the first element, which would be getting out, right guys? So that's how we are going to use the this dot tail. And one very disadvantage of circular linked list, like which we need to take care very much, which is the traversing part. If you are not able to traverse it properly, it could go into the infinite loop. If you are not able to traverse your circular linked list properly, then it will go into the infinite loop because it's not going to end anywhere. So that's why your termination condition should be properly corrected. And our termination condition would be yes, no null this time, right? That's why it's problematic, and that's why our termination condition would be like this. Let me show you. So our termination condition would be wherever, like first we'll take wherever tail dot next is equal to head. Like in this example, I'm just simply taking this example. Guys, this is not a termination condition. This example I'm telling you. So in this condition, this condition could be this dot tail is not equal to head, or this dot head. Till that, traverse it. Till that, go inside it. But as we got tail or head, 1 minute, 1 minute, 1 minute. Not this dot tail. This dot tail dot next. Because this dot tail dot next is head, right? Yeah. So this dot tail dot next is not equal to this dot head. Till then you just traverse it. But once you got this dot tail dot next is equal to this dot head, you have to stop it. You have to stop it. It means you have already traversed it, everything. You need to stop it now. Understood, guys? That in this condition, this is the scenario. But did you guys understood the termination condition for this scenario? I know circular linked list is a little bit difficult, but yeah, we'll try to make it easy with the examples. So, sir, in other methods, can we use tail head is equal to tail dot next and use head like normal? Yes, yes, that's what we will do, Ekta. That's what we will do. In every operations, we will not take head now. If you see in their circular linked list, you can see they are only taking the tail for creating the circular linked list. While they are only taking the tail. And whenever we want to go for the head, we will do this dot tail dot next, and that would be our head. Understood, guys? So let's see if we have an empty. So let's see now. First see, because this is a single linked list node, single linked list. So node, if we talk about the node would be same. It will have two properties, well and next. Correct? So that's what, if we talk about the node in the circular linked list, it will be same as single linked list. If you want to create a circular double linked list, there will be one more property, that would be this dot previous. And if we talk about the circular linked list, so then there would be only two properties. This time we are not taking the tail, this head, we are only taking the tail. And tail is giving us one more advantages. That's why we are taking the tail part. Didn't get it. Which part, Arad? You didn't get it. Which part? The termination part, or why we are taking tail only, or both? Both. Okay. So let's start from there. Let's first understand. So did you understood what is circular linked list? First you tell me, Arad. You understood? Okay. So okay. So this is our circular linked list, right? This is our circular linked list. So in circular linked list, you can see always tail would be before head, right? Or head will always be after tail. Head like this. Head will always be after tail. If you have understood the circular linked list, then you know that the head will always be after tail, because the last element is going to point to head. Last element is going to point to head. So are we good with that, Arad? That head will always be after tail. Okay, we are good with that. So now when it is already predefined, when we already always know that head will always be after tail, so then why we will take the head pointer for our circular linked list? For our circular linked list, why we'll take that? Because whenever we want to go for head, we will do this dot date tail dot next. Go for tail dot next, that will always be head. Understood, Arab? That's why we are only taking one variable, that's called that's why we are only taking one pointer for our scenario, for our circular linked list. Yes, no need for taking head in our circular single linked list. So we are just not taking head because of that assumption. Yes. Right? Understood that part? Arad, you? Okay, now let's talk about the termination condition. Now let's talk about the termination condition. Right? So now in the termination condition, I'm right now taking head and tail again. In the same picture, I'm taking head and tail again. Right? So I'm saying where we will stop. So first we will stop from our first we will start from our head. We'll start from our head, then we will go into this part, then we will go into this part, and then in our while condition, we will check wherever we got a next which is equal to head, we will be stopping there. So if we are saying this is our tail, so tail dot next is equal to head, it means we have already traversed everything. Wherever tail dot next is going to be equal to head, we are saying that's it means we have already traversed everything from there. Understood? Because if we have reached to tail, so tail will be pointing to head, and we have already traversed head, so we can check this part that tail dot next is not equal to, it should not be equal to head, then only we should traverse. If anywhere tail dot next is coming equal to head, we have to stop it. It means we have already traversed it. Understood? Sir, in that case, we need head, right? No, we will say, okay. So we will not head, right? So see, what we will do. So let's see. That's what I was, okay. So termination condition, you guys are confused. So see, guys, I'm saying this is my tail. I'm just taking one pointer, which is this is my tail, right? Now this is my next node. And why I'm taking two here? I'm talking about the single linked list, right? Why I'm taking two there? Yeah, this is our 4. This is our 5. This is our array yaar. I'm again taking double linked list. This is not good. See, this is I'm getting confused between single linked list and double linked list. Yeah. So this is 5. This is 6, right? This is 7, and then this 7 is pointing out to here. Correct? This 7 is pointing out to 4. So now you can see this is our circular linked list, right? So now you can understand, we will take let head is equal to this dot tail dot next, right guys? So now our head will be pointing out here because this is the head from where we will start our traversing. Understood? This line you understood, everyone? Understood, everyone? This line? Yeah. So now we will start traversing, and we will do the traversing till we got tail dot next is equal to head. So now our condition would be like this: while this dot tail dot next is not equal to head, traverse it, and would be like head is equal to head dot next. Just move your head element, or no. Yeah. Wait. Then this condition is not correct. Wait. This condition could be correct there. Oh no. No. This condition will not work then, because now our head is changing. If our head is changing, then head will go here, and then head will come here, right? And after that, yes, I think then this condition is not correct actually. We need to correct the condition, and our condition should be head dot next. Head dot next is not equal to tail. 1 minute, let's think about it, guys. In this scenario, what will happen? Let's think about it. What will happen in this scenario? So see guys, we are at the tail position and this is our head. We have started traversing from this place, correct? So first we will traverse to this head. We are just moving our head. So now head will be moving here, then head will be coming here, right? And then our head has to come at this place also, right? And then we will do the head dot next. Right. Yes. So our condition would be head dot next, should not be equal to tail dot next. Yes, that would be our condition. While this dot tail dot next should not be equal to head dot next. Yes, this would be our condition, guys. And then head is equal to head dot next. You can see I just move head from here to here to here, then here. Once head had come into this position, I will check head dot next, head dot next, head dot next is equal to tail dot next. Yes, it is. Then we will stop here. Then we will stop here. And then this are traversing. So that's what, guys. In circular linked list, traversing is very complex. Traversing is little bit complex. So that's why we need to think about the logic clearly, that how our loop is going to. And I'm not saying this is only one way to traverse it. I'm not saying this is only the one way to traverse it, but this is all. This is going to be one way to solve this thing. This is not only the one way. Okay, guys. Now somebody is saying, sir, please repeat this. Head will be changed. I think already repeat this. Joseph, you want to again? So please let me know again. Head will be changed while loop will not satisfy. Yes, that's what we are doing it. Use a current, sir. Use a current, sir. Okay, we can also keep head as a constant and can use var like temp. So we need head in this. Ah, okay. So you guys are confused with the head now. Okay, okay. I was just taking this head as example. You can take current also, right? Hey, you can take the current also, right? Hey? This could be a current. This could be our current, right? This could be our current. This could be our current. We do not need head, right? Already told you, right? We do not need head, right? We do not need head like that. It's a header, just a pointer. If somebody is telling you to get the head, you can simply say let head is equal to this dot tail dot next. Or, or, or you can take the head, no problem. I already told you, right? We can move head also. Already told you we can move head also, right? If you want to move it, tail, see, in the doubly linked list, you can see we are only considering one variable, which is this dot tail. That variable should not be changed. That variable should not be changed. So we are keeping tail at same position. Whatever other variables we are taking, we can move it. Understood, everyone? We can move our head. That's just a just a temporary variable which we have taken, temporary pointer which we have taken. Okay. Understood, Hariharan, Joseph, Arad? Anywhere confused, let me know. So in this question, always the tail would be the important one, where we need to take care, where we need to think about. We just traverse here, right? Yes, we just traverse it. We have not inserted anything. We just traverse it. Okay. So now let's talk about the insertion. Now let's talk about the insertion. If whole list is empty, so tail would be, so in the double linked list we only have the tail, right? Which would be pointing out to null, right? Only one variable is there, one pointer is there, right, guys? Okay, so sir, the traversing condition is now head not next is not equal to tail not next. Yes, right. That would be a condition. I believe it will stop there. We'll check that. We'll check that with code. Then our loop will end when tail and head are in tail. Yes, our loop will be stopped there. That's what we want. That's where all the elements will be traversed. Right, Hariharan? We started with head, the first element, and then we reached at the end element. That's what we want. Again, if you want to take head, you will do again this dot tail dot next. You will get the new head, new pointer for head, new pointer for head. It will reach the tail, right? Why not? Why not? It will reach the tail. Once it will reach the head, tail here, then only it will, this condition will fail, right? Once it will reach head here, then only this condition will fail. When then you will check head dot next, which would be 5, and tail dot next, which would also be 5, then this condition will fail. Understood? Yes, Saran. We have to stop when the head dot next is equal to tail dot next. That's right. Understood? Okay, so now let's insert when the loop is empty. When loop is empty, right? Loop nahi, linked list. When our circular linked list is empty. Okay. So now what we need to do, guys, in the insertion case, right now create a new node that would be 4, which would be pointing out to null, right? In starting, this is step 1, but this is circular linked list. So first, this element has to, because this is the first element, guys. That's why this element has to point to same element, like same element. Like it would be new node dot next, would be new node only. This would be circular linked list. And this new node would be this dot tail. This dot tail would be our new node also. Correct, guys? This is the first element which has inserted. Like if you talk about the queues, so this is our queue. This is the first element 4 which got inserted, and that is at the tail position. Okay, guys, this is our tail right now. First one element, first element, and which will be pointing out to the same. So it will look like this: 4 next pointing out to the same. 4 would be pointing out to the same. No, not like this. This will be a double linked list, like this only. 4 would be pointing out to the 4, and this will be tail. Understood, everyone? If our linked list is empty, the element will be pointing out to the same. You can see here the code. I'm not sure I have written it or not. Yeah, I have written it. You see, first I made this dot tail is equal to node, and then this dot tail dot next is equal to node, which is same. New node dot next is equal to new node. Rather than that, already pointing out that first I pointed out to this dot tail, so that's why I was doing next on that. Otherwise, we can do node dot next also, and then this dot length plus plus. Understood the code, guys? Everyone? Let's look for the next element. If we want to insert from the start position, if we want to insert a next element in from the start position, then how will this look like? Okay. So now it would be a little bit difficult to understand, but yeah, please try to understand. So let's see. So 4, 5, 6. Let's take the little bit bigger example, so we'll better understand. 7, and then it is pointing out to 4. This is our tail. Correct, guys? This is our tail. Now let's first understand the append. Append would be easy to understand. Then we will understand the prepend. Okay, everyone? Let's understand the append first. Where we have to end from where we have to insert from the end, because we already has the end, right? In this example, this is our end. Tail is our end. And we have to insert at this position only. Correct? So what we will do, we have to insert like 8. We have to insert at this place. Right, guys? We have to insert this 8 at this place. So what are the changes we need to do? What are the changes we need to do? So 8 would be pointing out to null right now. Right? So first thing, whatever tail is pointing out, whatever current tail is pointing out, 8 also has to point out everything. 8 also has to point out everything. Right, guys? Whatever 8 is pointing out right now, tail also has to point out. This is the first thing we need to do. I think append is more difficult. Append is more difficult. I think prepend is easy. I will tell you why append is more difficult. But first, yeah, let's understand. Yeah. Append is more difficult. I will tell you why. See, so yeah, who was saying it and confusing? Who was that? Hariharan. So yeah, Hariharan. So this one is understanding, right? The first line. I didn't tell you till now the confusing part. This one is easy, right? Because we want to insert at this place. What is the tail? Tail mean at the end, right? If we talk about the similar single linked list, it looked like this, right? 5, 6, 7, 4. This is our tail, right? In single linked list, and here we will be having null. So we want to insert at this place in the same scenario. But right now this 4 is our like the last element 7 is also pointing out to 4, and we have made the 4 to 5 also. 4 is also pointing out to 5. This is the connection, right? That's what the that's what the circular linked list is. Last element will point out to the first element, or tail will be pointing out to head. But like whatever way you want to understand, tail would be pointing out to head. This is our head, right? From here everything will start. So now we want to insert at this tail place, append. So that's why the first thing is easy. Whenever the new element will come, so new element dot next is equal to going to be tail dot next. Tail dot next. Understood? Understood, Hariharan? The new node dot next is equal to tail dot next. Did you understood this part? Now the difficult part is this connection actually. That's why I told you this connection is difficult. This connection. How will we make this connection to 8? How we will make this connections to 8? 1 minute, 1 minute. I think no. This is not difficult, I think. Wait. Let's think about it. No, actually, this is not difficult. We do not need this connection actually. Hey guys, actually we do not need this connection. Oh yeah, that's right. I was just getting confused. 1 minute. We do not need this connection. Because 4 will still be same place. We do not need this connection. See, the output would be like this. Our output after this, after insertion 8, will be like this. 4, 8, and 8 would be now tail. And then 5, and then 6, then 7, and then 7 will be pointing out to 4. Right, guys? So yeah, it's not difficult, right? So now what we need to do, yeah, I think so first thing is correct. So new node dot next is equal to tail dot next right? And then tail dot next is equal to new node, right? And then this dot tail is equal to new node. This dot tail is equal to new node. So now you can see this is our tail. Now we have appended it. We have appended the new element at the end. Understood? I was just getting confused with the 7 line, but that's not true. Append is easy. That's why I was thinking append was easy. Understood, everyone? After 4, yes, that's right. Yeah, tell me, Ekta, what is your doubt? Yeah, please ask. Yeah, Ekta.
Hello. Sir, can you show that code? Yeah, that.
Mm-hmm.
Yes, sir. So here, when we say that currently before inserting, in this example, 4 is the tail, right?
Correct.
So the tail is always the node to which the last, like suppose, generally 7 we can consider as the last element.
Right.
Technically it will point to 4, and 4 will all like the node to which the last element of this linked list points is the tail. So but in second case after inserting 4, so why will the tail change? Because technically speaking it should always be like the element to which the last element points, right? So idhar confusion hai, like why is 8 the tail
I think,
getting
yes, yes, I understood the reason. So the confusion is you guys are visually understanding what is tail. You guys are visually
yes sir,
understanding try to tail. This
yes
is not
right.
tail now. This is not our tail now. Wherever I will
4.
write the tail, that would be our tail.
Okay.
Visually it looks like in this list this is going to be our tail, but नहीं ऐसा नहीं है. अगर हम इसी लिस्ट को अगर हम इसी डायग्राम को if we make this diagram like this 4
Yes.
5 then 6 then 7, now where will be our tail? Can you tell me where our tail is? And like this, yeah, now can you tell
Okay.
me where is our tail?
Okay. So tail is not something like it's not an hard and fast rule. कि tail वही element होगा. It's just that the tail will be anything at which we want to point to, right? कि
Yes.
अभी it's
नहीं
like
जहां से
getting
लिस्ट
shifted.
no, see, where when we are starting our circular link list, we will start in inserting elements, right? So we will be
Hmm.
moving our tail according to our own way, and that's why
Okay.
we are
Okay.
saying,
Okay.
yeah, this would be our tail first time. So that's why you can see, right? When I inserted first element, I was pointing out to that tail. Now when we will insert
Yes.
the next element, when we will do the prepend, then the next element would be inserted here.
Okay,
Tail
sir.
will
So
not
basically,
be
our tail is moving according to our requirement. जैसे हम उसको move करा रहे, it's just moving.
correct.
But
Yes,
हाँ.
and tail will always be stay at this place.
Okay.
Wherever you
So but
decided that is
हाँ.
going to be tail, that place only tail will be stay.
Okay. So basically, we have given it a flag like you be the tail, and just to avoid confusion कि किसी भी state पे at least एक tail हमारे पास रहे. So it is
Correct.
getting shifted. जैसे कि अभी आपने 8 shift किया, 8 को insert किया तो next
Correct.
if we want to, so this was append, right?
Yeah, this was
Append.
a pen. Yeah, this was a pen.
Append means inserting at the last. So suppose
Correct.
एक और अभी अपन को append करना है. So if we suppose we insert another node 1,
Right.
so it will come after 8,
Yes.
between 8 and 5,
Right.
and
Right.
then 1 will be tail, right?
Yes. So now,
Just like we did right now.
if you want to insert the one, so
Hmm.
now it would be come at this place. If you want to append, if you are trying to append it,
Yes, sir.
so yeah,
Okay.
so this will be 7 here, and then
And
7
it
will
will
be
point to
pointing out
4.
to 4.
And
Now
now
1,
1 is the tail.
correct.
Okay, so I understood. Now I understood that confusion was there. Okay.
No
Thank
problem.
you, sir.
I hope this clears some more doubts for other peoples also. What is this? This tail is equal to new node. Oh yes, Joseph, this is required, right? Because we are changing our tail now. Earlier our tail was 4. Now we have appended. It means we have inserted a new element. So at the end, so now our end element would be our tail. I know you guys got confused with this structure, with this diagram, because 7 is at the end. So you guys are thinking this would be always be our tail. Whatever is coming at the last, that is the end. That's not right. In this circular link list, we are creating our tail. And then, so see, it is not like the tail is going to change every time. It's only going to change when you're appending. If you're doing the prepend, this tail will not change. So now let's talk about prepend also. Insert at the starting place. Let's do the prepend also. Prepend, right? Let's take the same example. 4, 8, 5, 6, and 7, right? And here our tail is, right? And we want to do the prepend. We want to do the prepend. So what is prepend? Prepend means is insert at the start. Prepend means insert as the start. So what is our starting position, guys? Our starting position is this one. Whatever is coming after tail, that is our starting position. Right, guys? What has happened with my marker? 1 minute. Whatever is coming at after tail, that would be our start position. So we need to insert now, like 1. If you want to insert 1 at the prepend position, so wow, now what will be our answer now? 4, 8. I'm not sure what happened at the end with my marker, guys. It's working very slowly. 8, then 5, then 1. Sorry, 1, 5, 6, 7. Right, guys? And now tail will still be there here. Tail will still be at 8 position. Now you can see after tail at the starting position, we have inserted our 1. Now this 1 would be our starting position. Right, guys? That's how you need to visualize it. Visualization is very important here. Without visualization, you will not able to change the pointer. This code, whatever code we are writing here, new node.next, tail.next, this will only come after visualization. After visualization. Did you understood this part, guys? When I said about the prepaid, when I talk about the prepend, yes, it's working so slow. Let's try it. Let me close the OneNote. No, this time it is actually not working at all. Not sure, but yeah, still same. But yeah, first let me know in the chat, did you guys understood that? That the when we are doing the prepend, did you understood? So now see what would be the code here. So now for the prepend, so what would be, so this is our original scenario. This is our original scenario. What will happen in the prepend scenarios? So now new element 1 has to be inserted here. So now first we need to break our connection with this dot tail. This dot tail will be pointing out here. And then whatever is coming in this dot tail dot next, that has to come in 1 also. So now the code will be like this, guys. New node. Now it is working fine. I'm not sure why. New node dot next is equal to this dot tail dot next. So when we will do this dot tail dot next, we'll get 5. And then we will insert that 5 connection here. Right? New node dot next is correct. Now we need to update the this.tail.next also, this.tail also. So this.tail is equal to new node. I think that's what. And this.length plus plus. I think other than that, we do not need to do any other thing. Right, guys? Let's see our code is correct or not. So new node.next. So like the new node address. So this address, his address should be 5. So new node.text. And how we will get this 5? We'll get from tail only. So this.tail.next will give us the address of 5, which we will keeping it here at the 1 position. And then this.tail. 1 minute. This.tail not next. Sorry. This.tail.next. Not this.tail. Otherwise, one will become new node. Guys, this line I have written correct wrongly. Let me correct it. If I will make this.tail is equal to new node, then one will become this.tail. Otherwise, no, we don't want to do that. We just want to change the position of next, which would be this.tail.next is equal to new node. Correct, guys? Now this is the code. Let me know if you guys have any confusion. Sir, it is prepend. Why are we changing tail? We are not changing tail. We are just changing the pointer of tail. We are just changing the pointer. Yeah. That's what. Okay. So new node dot next. We will tail dot next. Yes. And tail dot next. Yes. Joseph, this dot start is equal to new code. This dot start is equal to new. Okay, so you're talking about the start. This dot start is equal to new node. Yes. This dot start is equal to new node. No. Start is the start is the position where would be the new element will be. Start would be the position which will come after tail. After tail, what will come, Joseph? You tell me. After tail, in the circular linked list, after tail, what will come? New node, right? Yes, start. I think start would be the correct answer. So after tail, start will come, right? And what we want to do, prepend. So we want to insert an element at the 0th index before starting. So that's why the one has been inserted before 5. Earlier our start was 5. Now our start has become 1. Understood? Everyone understood? Okay. So see, guys, now we want to insert at any specific index. So everything is same. Let me draw it quickly. Same thing, same one. 1, 5, 6. Let's take this is our tail. And we'll take the element like this 0, 1, 2, 3, 4. Correct? Correct, guys? From here, from like that, we are only considering, right? 0, 1, 2, 3, 4. Right, guys? So now if you want to insert something at the second position, I think this is very easy, right? You have to start from here. That would be very easy. I think no need to understand this thing, right? This dot tail dot next will give you the head, this position current. And then you will do the same while loop. You will reach at this place, current, then the previous, as you did in the single linked list. You will reach here. See, in the circular linked list, just one thing has changed for you. In circular linked list, guys, just one thing has changed for you, which is you do not have head now. You do not have any direct head pointer, but that you can get from this dot tail dot next. That you can get from this dot tail dot next. Other than that, anything got changed. Other than that, anything got changed for you in the single linked list. You guys tell me. Other than that, anything, if you want to do the insert at any position, and removed from the any positions, did anything will change for you? It just you need to, if you want the start, you will always get it from the this dot tail dot next. You want to get his head or start. Every time you will get it from the this dot tail dot next. Agree? Everyone agree with that? Yes, that is totally same. Insert at any index is totally same code. It's just one line change in the single linked list. Earlier you were taking current is equal to this dot head. In the single linked list, if I show you, in the single linked list, while inserting at any position, where is that code? Yeah, insert at any position, you were taking this dot head, right? Instead of that, what you will do in the case of circular linked list, you will do this dot this dot tail dot next, right? That will give us head, and then same code will run. Yes, any node after tail, it's a start, right? Yes. Yeah, Harim, please ask. Same goes for remove also. Let's hear what Hariharan wants to say. Yeah, Hariharan.
Yeah, sir. Am I audible?
Yes, yes, you are.
Can you please go to the repo single LLP?
Mm-hmm.
So remove at position or insert at position. Anything is okay, sir.
Sorry, I didn't understand what you say.
The method you have written, right, sir? Just line number 58, sir.
Yeah.
Actually, first line number 56 you have written if position equal to 0, right?
Mm-hmm.
Like that in else if position equal to this dot length you have written. But how come this dot length will work, sir? Because we are starting the position from 0, right?
Mm-hmm. So
Then
like if somebody is passing position
okay,
which is equal to our length, like
okay,
if in our linked list, if we have five element we have inserted,
okay,
right?
yeah,
And so our length of linked list would be 5, right?
yeah, yes,
Okay, so you mean you want to say this dot length minus 1 it should be, right?
yeah. I think
Yes, yes,
I'm
that's right.
confused.
Yes, that's right. It should be 5 minus 1 because if in the linked list 5 elements are there, then the index wise they would be fourth element. That's totally right.
Yeah,
0, 1, 2, 3, 4. Yes, that would be fourth element. So if somebody is passing position as a 4, then it means we need to do the append. That's right.
yeah, yeah. Okay, sir.
Understood, understood. Yes, that's right. So guys, Hariharan has made very valid point for the last condition, for this condition, right? That is saying that if our position, we are taking from the indexes, right? And our indexes start from 0, right? So if our position is equal to this dot length, it means we are saying that the for the fifth index, because this dot length would be 5 for 5 elements, right? And and from the index point of view, that should be fourth element. So that's why position is equal to length minus 1 would be there. That's totally right. So yes, guys. So I know there would be some of the it's still little bit confusion. I believe you guys will having in the circular linked list or not. You guys tell me first. Did you guys have any of the doubts in circular linked list? Is still, I believe if you if you have already seen all the singular linked list and double linked list, and if you have seen how the circular linked list is working with just a diagram, just remember, guys, this diagram. You can see this diagram. Just remember this diagram, and after that, you can easily code it. Okay. What about others? For Vishal, it has become very easy. He has to now do the practice only. Concept wise, I believe everyone would be understanding these things. I think now linked list is done, guys. Today we have completed linked list. That's all the scenarios. Now there are a lot of problems in linked list, and that we are going to look into our next class. And I think Reliable has started one more policy. They are saying that from the next class, I have to take the assignments parts also. So I would requesting to you all to look for the assignment questions which they have provided for the linked list part. And I want you to first practice it. Whatever we have done, create a lot of diagrams. Like take the paper, pen, and create all the diagrams. Start from single link list, and start creating insert at start, insert at end, insert at middle, remove at end, remove at this, remove at end. Do for this, do for in single link list, do for double link list, just in diagram. First do that, first in diagrams. Same do for circular link list. Once you are comfortable with all these three, start practicing the code. And I think once you will understand one code for single link list, you automatically, you no need to write the other code for double link list or circular link list, because everything will be repeated after that. So that's why. But yes, on drawing, please do everything. On drawing first, do the single link list with all the operations. Do the double link list with all the operations, and same goes for circular link list. Okay, and after that, look for the assignment questions. Okay, try to answer those assignment questions, and in the next class, starting some time, we will take to answer those assignments questions. First, I will ask you guys to tell the answers and what you guys have understood. Then I will try to answer them. Good, guys? Okay, so sir, one doubt, what it literally means, this dot tail is equal to new node. So literally means now tail is going to point new node. Tail is going to point new node. So see, Joseph, if we have created a new node here, right, like this, if 5 is a new node which we have created, and if we are writing like this dot tail is equal to new node. So we are saying this tail is now pointing to new node. So now this tail will be pointing to this one. Understood? Understood, Joseph? The literally meaning of that? Okay, so everyone, I have given you yeah, same with path. Whatever is on the left side, it means we are pointing to somebody or copying it. Okay, so what I was saying, yeah, so I have given you one path because we have long holiday, right? I think we have now from today till Friday. So this is, I think, enough for you guys to look into this one. Okay, guys. So that's all from today. And I want you guys to be like fully confident on the linked list. And then we will, if you got little bit time, like after doing everything. So then start from some of the problems, like reverse the linked list. I will give you one problem, just little bit thinking is required there. Reverse the single linked list, not circular or double linked list. Reverse the single linked list. That would be the problem. If you guys have already completed whatever I told you, assignments, all the practice situations, just you do that, and then we will start with then you have to solve the reverse the linked list. So Deepak is asking about, can you help with recursion? I'm not sure if it is in the earlier topics, but if you want, like if you all guys want the recursion topics, you can talk with Ansul, and then we can have a session on recursion, just 2 hour sessions or anything. Okay, and then we can talk about the recursion fully. I think recursion is very interesting topics. Lot of problems are there which could be solved with recursion, or with the iterative approach also, like with the while loop or for loop also. It's not like that recursion is only going to help everywhere, but yes, recursion, like if we talk about the dynamic programming scenarios, so recursion gives us the ideas I would say that. And then we can convert those ideas into the iterative approach. Sir, what part you have given us? I didn't understand this question. Okay, didn't understand your question, Hariran. To do by yourself, to do by yourself. Okay, so do for yourself is the yeah. I mean the questions. Yes, that's right. So first, I told you to first do all the operations on these linked list in your papers. All the insertion in single list, remove all the remove scenarios, right, in the papers. Then do for double linked list, do for circular linked list. After that, try to solve your assignment questions. If you are stuck somewhere, just leave it there. No problem. We will talk about it. But yeah, you should be stuck somewhere. You should think about it and then stuck. It's not like that you read it and just leave it. Okay. And then I'm telling you that try to solve one question, which is how to reverse a single linked list. Most like already answers is available in Geek or everywhere. If you want to solve it, you can check those answers also. But we will also talk about it if we have it in our second session. Okay. So after doing some questions, I forget then what to do. Yeah, it happens actually. Deepak, with everyone it happens. When we start solving some questions, so see, I would say that try to relate that question. See, in the starting, if you are trying to solve 4 to 5 questions, those all questions are totally new. That's okay. If you are stuck at that place, that's fine. That's naturally. We do not have seen things. If we are seeing it first time, it will be always new for us, right? But once you did like a lot of problems where you are stuck and you have solved it, you have seen the solutions after thinking a lot, then you're stuck. But after that, your habit should be you should relate your problem with the problem which you have already solved. Somehow you have to relate that. Somehow you have to find that pattern. And there would be definitely some patterns. So that's why starting 30 days, do all the new questions. Do all the new questions. If you're stuck, think about like 30 minutes, think about that. If you're not able to solve it, check the answers. Do not feel like I am just dumb or anything like that. I cannot think about, I cannot be a good programmer, so I cannot be a good coder. Do not think like that. Everyone follows the same thing. Whoever is right now in the expert level, they have also gone the same flow. They have also gone the same track. They have also stuck at that. I also stuck at same pace. Then what I did, I just followed these new questions, and then once I did the new questions, like there are a lot of patterns, like sliding window patterns are there, hash map patterns are there. So these type of patterns, then we start. Then I'm getting any new questions. I just use that index memory which I created while solving the problem. So that's okay. Okay, that happens with everyone. Okay, guys. So that's all from today. Happy Dasara, everyone, and enjoy. Okay, something happened. Okay, now we're good. Yeah. So yeah, happy Dasara again. Yeah, in advance. And yeah, so let's connect back into next class. I have given you a lot of tasks to do, so please do it. Thanks, everyone. Have a good night. Bye bye.